In the last couple of videos, we learned about microservices. And microservices are these small little chunks of code, these specialized applications that we're going to run, and they're all going to integrate and communicate with one another. How are we going to run those? Well, the ideal way is to run them in containers. I'm not going to run those microservices in individual virtual machines. I'm going to run them in containers. So containers solve a few problems for us. And the first problem that they solve is, how do I get software to run reliably when it's moved from one computing environment to another? So, for example, software is potentially developed, let's say, on a developer's laptop. They create this software, and eventually, when they're ready to test it out, they deploy in a test environment. And once the testing is complete, the software moves to a staging environment, and then eventually into production. And so it may start on a physical machine and then be deployed on a virtual machine in a private cloud, or maybe even in a public cloud. And all of these environments have these little differences, like software dependencies and security policies and the networking environment. And all of those little variables can cause the application to potentially malfunction. So how do containers help us overcome this? Well, a container includes the entire runtime environment of the application. It includes the application itself, all of its dependencies, all of its libraries, configuration files that are needed to run it, and other applications that are built into this one little package. And it's like it's running in its own little bubble. So now I can take this containerized application and I can move it from platform to platform. And that's where the name containers came from. That's where Docker came from. Where basically, think of a shipping container. It's this self-enclosed environment that I can put on a cargo ship, I can take it off of a cargo ship, and I can put it on the back of a train. I can move it from one platform to another without impacting what's inside of that container. And so with a container, the little differences in operating system distributions and the underlying infrastructure are abstracted and they're hidden from the application running within that container. And so you may think, well, wait a minute. I've got virtual machines. Maybe I'm running vSphere from VMware, and I've got an ESXi host, and I've got a bunch of virtual machines running on my ESXi host. I can move those virtual machines around anyways. So what's the difference between a container and a virtual machine? Well, in this example, let's say I've got an ESXi host, and this could be Hyper-V, this could be pick your hypervisor, right? Any hypervisor that's running virtual machines. Every single virtual machine running on top of that hypervisor has to have a complete installation of an operating system. So now I've got my physical server here, my ESXi host, and again, substitute whatever hypervisor you want here, but this is my server, and on top of it I got these 4 VMs, each virtual machine running its own independent operating system. And so number one, I'm consuming the overhead, the memory requirements and CPU requirements of running 4 individual operating systems. They might all be the same operating system, but I'm still running 4 instances of that operating system. And so now I've got all of these applications running on top of those operating systems. And so let's think about this from the perspective of a developer. I've just written this great new application, and now I want to deploy it. I basically have to count on the operations team to have all of the necessary dependencies built into my operating system. So I've written this application, but it needs certain things, like a certain version of Java or whatever. If the operating system team doesn't have that set up correctly, my application isn't going to work right. And so this can be frustrating for the developers, and it can create delays in getting software to production. And what if I have another application that requires a different version of Java? Well, now I have to maintain that difference across these multiple operating systems. So a container is different than a virtual machine. Even though they share some of the same characteristics, a VM requires us to package the entire operating system, right? So in this diagram here, I have 4 virtual machines, each of which is running its own independent operating system. And I've got an application running on each of those VMs. Let's compare that to containers. Here I've got my operating system at the bottom here. Could be running on a virtual machine, could be running on a physical server. Regardless, we've got a single operating system here. We're not running 4 different VMs with 4 different operating systems in order to run 4 applications. So I take my operating system, and on top of that, I create a layer called the container engine. This is going to allow containerized applications to run on top of this operating system. And so now I've got these 4 containers all sharing a single instance of the operating system. And there are shared parts of that OS that are read-only. And each container has its own mount. So it has a way to access that container for writes, for things that need to change. So the containers are much more lightweight. They use far fewer resources than virtual machines because each container doesn't need an operating system. Each container takes up less space than a VM. So now I can run many containers on the same storage where I would be able to run much fewer virtual machines. And I have less CPU and less memory overhead as well. But we do need the right operating system underneath the surface. We do need a compatible operating system in order to do this. So we're going to call this the container host operating system, or the container host OS. We need a registry where developers can put their applications. Think of the registry as like a library of applications. And when they're done developing the application, they can take it and put it in that registry, and we can then deploy it on the spot. So the platform for that container application to run is already here. And the container does not have its own operating system, so these things boot up very, very quickly. And there are these binaries and libraries and config files that each container needs to run. So these are software requirements and files that each container needs. I may have multiple containers with the same requirements, or I may have containers with different requirements. So for each of these containers, we're going to define the binaries and the libraries that they require. And so I could actually have multiple containers sharing the same underlying binaries and libraries, and that makes the containers even more lightweight. So my container host must have a standard operating system that we will declare the operating system that we want to use here. And if I'm running vSphere in an on-premises environment, Photon has a container runtime baked right in. This is important if you're looking at running Kubernetes on top of vSphere. That's one of the ways that we can run containers. So we could create VMs in a traditional virtualized environment with a certain operating system. Those VMs could be our container hosts. So let's start with the first ingredient here. We've got source code. This is our application, our source code. Now, what files does this require to run? What operating system should it be running on? Those are going to define our dependencies. And so now we've got this source code. We've identified all of the necessary dependencies. Now that we've got everything working perfectly, we can feed this into the container engine and create an image based on what we have created here. This is kind of like creating a template based on a perfect image of what this container should look like. Now I've got all of the ingredients for my container, and I'm going to publish that complete package to a registry. And now we can simply launch containers from that registry. So there's a few key terms that you have to be familiar with shown on this slide, right? Of course, we've got our source code. We've got the dependencies, all of the things that my container is going to require. The container engine that we're going to feed it into, and we're going to create an image. And I can spin up many instances of containers based on that image. And then I've got a registry. That's my library of all of the containers that I've created.